Gando in Burkina Faso, West Africa. A unique project is being unveiled on this day. The legacy of the late Christoph Schlingensief. After the artist's death, his widow, Ina Laberenz, carried on with his plan to build a refuge for an opera village in the heart of one of the poorest countries on earth. When completed, the village will consist of a festival hall, living quarters, an infirmary, and a school. Architect Francis Carré developed the village along with Schlingensief and now oversees the project. He's a native of Burkina Faso, but has spent much of his adult life in Germany.
It's an absolute necessity in Burkina Faso. This is one of the poorest places on the face of the earth. We've tried to construct the dwellings so that people can get by without artificial air conditioning or ventilation. That's why I developed the idea of using local materials. That forces one to conceive buildings in a different way.
Carré's idea? Floating rooftops that provide circulation and protection from rain. And there's another unique feature.
Inside, you can see the double roof, a massive ceiling and a lighter one. Together, they function a lot like a lung. We cut slits into the massive ceiling so that heat can escape.
And that keeps the temperature inside at a comfortable level. Outside, it's 40 degrees centigrade in the shade, but it's comfortable inside the school. The architect spurned expensive imported building materials. Instead, he relies on clay soil, found abundantly in the area. The project got off the ground in 2009 and has employed dozens of locals. At first, many were skeptical. Clay is considered a poor person's building material in Burkina Faso. So Carré first had to convince the locals. Once that was accomplished, he also taught them how to build their own dwellings, a step towards independence.
Human beings are at the heart of this philosophy. So many young people live in Africa, they want to work and are enthusiastic. Take these two traits, add a little clay, and you can build homes.
At present, 50 children attend the new school. In addition to reading, writing, and arithmetic, they're introduced to art and music. The founders of Opera Village were adamant about that. A recording studio and ateliers will soon be added. Since Schlingensief's death, Laberenz and Carré have labored tirelessly to make Opera Village a reality. An auction of artworks in Berlin has raised more than €1 million for the Opera Village, which means the next phase of building is now also covered.
It's an enormous challenge. The bureaucracy, finding a way to finance it all, and convincing potential donors. But I also try to remain as involved in the actual project as possible. I want to stay up to date, especially as to immediate requirements. My fervent hope is that the village remains open and autonomous.
The people who live and work here hope so too. Further buildings will be under construction soon, the infirmary and a sports field, and the festival hall. The South Korean capital, Seoul, a bustling metropolis of 10 million inhabitants. Near the city center, the privately run Ewha University with its newly completed campus center. Ewha is Korean for pear blossom, a reminder of the pear tree that once grew in the yard of the Methodist missionary who founded the university in 1886. She wanted to give young Korean women access to education and convert them to Christianity. Much of the campus center is below ground, a peculiar concept for Asian sensibilities in a region of soaring skyscrapers. The subterranean plan was hatched by French architect Dominique Perrault. He calls it the Ewha Valley.
This valley is much more than just empty space between two walls. This is where architecture truly disappears. What I mean is that the absence of architecture makes it possible to entirely rebuild the topography. I can create a new landscape within that which already exists.
70,000 square meters of underground space. The valley slices through the entire area, seamlessly integrating the campus with the surrounding Sinchon district. And on the rooftops, traditional Korean gardens, shrubbery, grass, and pathways, a place of relaxation for both students and professors. Ms. Young Kang is a professor of architecture at the university. She oversaw construction of the campus along with her colleague Yoon-hee Lee. They also designed the verdant rooftops, which play an important role as energy provider for the buildings.
The roof arcs and the underlying layer of soil provide insulation, so in the summertime there's protection from the powerful rays of the sun. And in winter it keeps the cold out. So inside we can keep temperatures at a constant, comfortable level. The roof also influences a subjective sense of well-being.
Metal pipes on the roof suck a constant flow of fresh air into the building. A thermal labyrinth provides a natural form of air conditioning. The incoming air is guided slowly downward between the concrete walls. The thermal capacity of the soil either provides warmth or cooling, depending on the season. The air is then channeled into individual rooms, a system that is highly energy efficient. Even the classrooms at the very center of the complex have access to excellent air quality. In an effort to bring more natural lighting inside, gaps have been left between the floors and the impressive plate glass windows.
This is largely a subterranean building, but as you can see, we don't have to turn the lights on. Other campus buildings have their lights on throughout the day. But the valley gives us access to light, so it doesn't feel like you're underground. Two glass facades allow plenty of sunshine. Even the smallest corners are lighted optimally.
An elevator connects the underground area with the roof and garden landscape. When weather permits, the expansive staircase is used as an open-air amphitheater. During the monsoon season, typhoons are commonplace, generating winds of up to 150 kilometers per hour. So the glass facade was reinforced with stainless steel blades, bolts, brackets, and canopies. The potential for flooding has been minimized as well.
The monsoon season comes during summer with heavy downpours. We use these to our advantage. The rainwater is captured through a drainage system and stored here in the valley. From cisterns, it's channeled through the entire building. The water is sterilized. It's used for the toilets and to water the roof gardens. The system is environmentally friendly to a very high degree.
The headquarters of the Fraunhofer Institute for Industrial Engineering and Organization, the IAO. In a virtual environment, researchers are creating a very special house of knowledge. The structure is nearly finished. The Center for Virtual Engineering will open its doors in mid-2012 and will allow engineers to design holistic industrial environments of the future. The building is packed with energy-intensive high-tech, and yet it's being touted as a prime example of green architecture. Vanessa Borkman oversees the project. She meets regularly in this conference room for planning discussions with the German-Dutch team of architects and the ASPLAM and UN studio firms. Here, the new research center is being constructed in a virtual environment. Today, they're discussing the climate control system and its effect on the health and well-being of employees at their workplaces.
As you can see, the air flows out of the duct and takes on a wave form as it circulates through the room. It changes direction at the opposite wall and flows downward.
For the first time, the Institute is using its extensive know-how in virtual reality to plan an entire building, complete with inner workings.
We can utilize virtual reality to better comprehend and visualize and benefit from the input of people who can't read a blueprint. It allows us a great deal of transparency early on, and that in turn helps minimize mistakes in the overall planning process.
Possible alterations can be simulated beforehand. Construction problems also come to light. In all, it's an ingenious way of lowering costs and fully utilizing resources. In the laboratory building, scientists are eager to forge ahead with groundbreaking research.
The Institute is visualizing the workplace of tomorrow. It's a synergy of space, structure, people, and technology. And of course, sustainability is also an important aspect, especially when you take into account the quality of the workplace surroundings and employee satisfaction. One has to consider which products go into creating a pleasant surrounding, what procedures must be put into place, how certain products will be manufactured, and in the end, recycled.
Architecture is only considered to be sustainable when aspects such as ease, comfort, and user-friendliness are taken into consideration. These are every bit as important as energy efficiency and maintaining an eco-balance. The building's energy is provided by a geothermal source, acoustic absorbers, LED lighting, and intelligent windows that open and shut automatically contribute to a comfortable workplace environment and increased energy efficiency. Concrete core cooling contributes to climate control throughout the building. Plastic pipes have been embedded in the concrete roof, and water circulates, warming or cooling depending on the outside temperature. The overall energy concept includes a sprinkler system fed by a massive holding tank in the cellar.
Along with the geothermal source and the concrete core cooling, we also retrieve excess heat from the laboratory areas. The many beams that we put into place channel that heat into the sprinkler tank, so it also serves as a large heat reservoir. And of course, we've put a heat pump into place. Those are the major components of our energy concept.
Within the foreseeable future, the groundbreaking elements in place here will be widely available. The Center for Virtual Engineering touts itself as an open laboratory and welcomes visitors. Its undulating form and open interior signify a desire for transparency in the research process. Dutch architect Ben van Berkel came up with the design. He's gained worldwide renown through his Mercedes-Benz Museum in Stuttgart.
The ideas were so organized that whenever you would enter the building, you would never have a dead end. You would always walk around. The building integrated itself with the existing structure. What is quite nice is that you would always meet people on the way. There will be always a possibility to communicate and to have informal moments. Wherever you have this formal aspect of the laboratorium space is connected to the offices. It's almost that if you walk in a kaleidoscopic space.
Van Berkel is already working on his next major project, a building for the University for Technology and Design in Singapore, planned using virtual technology and built with sustainability in mind.
We as architects dress the future, I often say. Maybe we are somewhere the fashion designers of the future, but if we dress the future, then we have to make sure that it is for people, that you can have a healthy environment, and that it is good for the environment itself.
Back in Burkina Faso, architect Francis Querré's home village Gando, 200 kilometers southeast of the capital.
This is my home.
Remote African villages pose a completely different array of architectural challenges than those faced in European and Asian cities. Without steady supplies of electricity and water, the people here largely make do with what they can produce themselves. They live in accordance with nature. Here, that means short rainy periods followed by long dry spells. Querré is the son of a tribal chieftain. He's the only person from his village ever to attend a university.
I've been very lucky. I've managed to broaden my horizons, but I also wanted to give something back to my family. My desire was to take the things I'd learned in Europe and use them for the good of my family.
That includes the local school. Children from throughout the region study here. But the school didn't always look like it does today. Even as an architecture student in Berlin, Querré sought to support his village. He founded a charity called School Building Blocks for Gando. Over a decade ago, he put all donations to use and built the first schoolhouse. His blueprint took climate and locally available building materials into consideration, and the design garnered him one of the world's most prestigious architectural accolades, the Aga Khan Award.
With a building or infrastructure such as a school, I like to embed it in the lifestyle of the locals. So I use materials produced in the villages, and most importantly, I make it sustainable, so that it'll have a long lifespan. That's why I resorted to clay in this case. I said we simply had to utilize it.
Querré developed a new kind of kilning recipe for the compressed earth blocks. 1/10 cement, the rest sand, soil, and water.
It's about finding the correct mixture. That in turn depends on whether it's the rainy season or the dry season, and whether there is high humidity. The mixture must be such that the compound isn't too moist, like this.
His recipe gives the blocks a longer lifespan and makes them water resistant. The bricks are formed using a machine Querré imported from Belgium. After they're formed, they're put out to dry in the hot sun.
The advantage of this technique is that the blocks don't have to be baked after they're formed, and the result is much more robust than the usual method. This region is a savanna, and there is little wood, so it would be absurd to produce standard bricks. Where would the energy come from? Everyone has a responsibility to use and preserve the available resources in a responsible manner.
This is the innovation that has won Querré so many accolades. A load-bearing steel truss allows the corrugated metal roof to float in the air, which cools the interior. The steel rods have another important advantage in Africa. They're impervious to termites.
Und wir haben natürlich einen Abstand zwischen der massiven Decke und dem.
There's a space between the corrugated roof and the ceiling.
Das Dach ist auch geneigt.
The roof is also at an angle. That promotes circulation. The wind blows through the broad space. So there's a constant cooling effect as the air circulates.
Gibt es eine Kühlung, eine ständige Kühlung, weil die Luft dann zirkuliert.
Over 700 children and young adults attend this school in Gando. It's already desperately overcrowded. Kere has ambitious goals. He's planning a high school for the older students. A soccer pitch and a cafeteria are also in the planning stages, and a library is under construction. It's all financed with the prize money from the awards Kere has received. Similar buildings have been constructed in Mali and Togo, influenced by Kere's unique architectural philosophy.
The locals love, protect, and care for these buildings as if they personally own them. That's because I got them involved in the process. Many more people must discover this source of pride. Then we'd have a bright future. I hope that many architects become confident enough to utilize regional resources and not import things that the locals have no relation to. That doesn't inspire innovation, only poverty.
Class is underway at the Ewha University in Seoul. It's reputed to be the largest private women's university in the world, with 23,000 students. The board of directors wanted to create an attractive campus center where students would enjoy gathering in between classes and even on weekends. It's open around the clock.
This is a university exclusively for women. Traditionally, it has been isolated from the surrounding urban environment. But when we planned the new campus center, it was important to extend an open connection to the general public. At the same time, our students should feel free to make this a part of their social life. We wanted to create a small city right in the middle of the university campus.
The variety is astounding. Everything from fitness centers to shopping. And there are movie theaters and cafes as well. In the lower level, exhibitions are staged, encompassing a multitude of interests. The privately run university is financed through tuition fees and generous donations. Its graduates are highly sought after, especially in the realms of medicine, mathematics, and architecture. The university offers majors in all of the classic natural sciences. It's a marvelous architectural achievement, fully integrated into its surroundings with an energy-efficient and ambitious climate control system, a model for similar projects worldwide.
These days, many countries are trying to reduce CO2 emissions. Since buildings have a close relationship with the earth, they should use energy from natural sources. That provides a high degree of sustainability. I believe that buildings used primarily for teaching can have a major influence, especially in a large university like ours.
Sustainable architecture comes in many variations depending on the local environment. But there is one unifying factor. The overriding goal is improving life for humankind.